Hello everyone, this is Travis Bates from MLC CAD Systems here to provide you with some best practices for 3D printing with Markforged. There are 6 essential rules that should be followed every time to guarantee successful prints. It is important to follow these steps as it will allow you to get the most out of your printer and printing experience, which will benefit you in the long run by minimizing errors that can cause delay. The 6 rules are as follows: proper leveling of the print bed, proper cleaning of the print bed, proper cleaning of the nozzles, applying fresh glue to the print bed before each print, knowing when to use Brim option or supports, and optimizing print orientation. The first one, proper leveling of the print bed, is probably one of the most important factors in making a successful part with the desktop and industrial series printers from Markforged. Before every print, it is important that you make certain that the print bed is correctly leveled and that the height of the plastic and fiber nozzles are set correctly. It is easy to tell if your plastic nozzle is at the wrong height. The idea is that the extruded plastic should form a road that is 0.1 millimeters high and 0.4 millimeters wide. If the nozzle is too close, the extruded plastic will be too wide and too thin. If the nozzle is too far away, the plastic will look like round stringy beads. There are 2 useful utilities to help verify that the print bed is level: bed level test print and the fiber nozzle calibration test print. For more information about leveling the print bed, please follow the link provided. Proper cleaning of the print bed. After leveling, proper cleaning of the print bed is probably the second most important factor in printing successful parts. You will want to use proper scraping techniques to avoid damaging the bed when removing parts. When cleaning the print bed, make sure to use warm water and a sponge for best results. After cleaning, you will want to dry the print bed completely with a lint-free cloth before putting it back into the machine. Proper cleaning of the nozzles. Plastic buildup on the nozzles can cause dislocations and tag your part with extra bits of plastic, compromising the surface finish. Proper cleaning can be done using a pair of tweezers, brass wire brush, and 800 grit or higher sandpaper. Before cleaning, make sure each nozzle is at room temperature. Start by using the tweezers to remove any large pieces of plastic from the nozzles. Be careful not to damage the nozzles while removing plastic with the tweezers. Next, use the brass wire brush to remove any remaining plastic residue. If there is any small stubborn residue, use sandpaper to remove that last little bit of residue. Make sure to fold the sandpaper to match the shape of the nozzle to make cleaning easier. Applying a fresh layer of glue is essential to ensuring your parts do not peel off the print bed during printing. By applying a thin layer of Elmer's glue to the print bed, you will prevent your part from peeling, warping, or curling, and it will also keep your part stationary during the print. Be sure to apply a layer of glue that covers the entire surface area of all parts that will be on your print bed. Using brim or supports. A brim is a special type of skirt that is actually attached to the edges of the model. Typically, a brim is printed with an increased number of outlines to create a large ring around your part, similar to that of a brim of a hat. Brims are often used to hold down edges of your part, which can prevent warping and help with bed adhesion. Use of supports is critical for certain features. Knowing when to use supports becomes easier using the 45-degree rule. The 45-degree rule in 3D printing is a general rule that suggests using supports for any object that contain angles greater than 45 degrees. Using the Eiger software, you can secure your prints by adding a brim layer or support. Take into consideration when the brim or support is needed, and follow the link provided for more information on using brims and supports in Eiger. Optimizing print orientation. Often an overlooked rule, but by orienting your part so that the largest, thickest side of the print is fastened near the build plate and the rest of the print builds up in the Z-axis, can opt for a better print build. This will give your print the best chance for success and require less support. However, optimal part orientation can depend on certain design factors. For example, you will have to consider which factor is more important for your application, such as surface finish, part strength, support usage, support removal, and print time when deciding on your ideal orientation. To the left, I have provided a couple different examples of part orientation based on certain design factors. For example, speed and build time. Part orientation can have a huge effect on the amount of time it takes to build your part. Generally, the shorter your part is in the Z-axis, the faster the part will build. The part on the left in the example provided would take much longer to build than the same part laid down on the right. Support usage. Support usage is also dependent on part orientation. Any overhangs must be held up by support material. In the example provided, the stand on the left would have a very large amount of support under it, whereas the stand on the right would use very minimal amount of support. Less support material will also shorten your build times. Surface quality. When there are curved surfaces on the top or bottom of the part, they will appear stair-stepped after being built. But by orienting the part with the curved surfaces positioned in the z-axis to the sides, the surface will appear much smoother. In the example provided, the wings and fuselage of the jet on the left will appear stair-stepped, whereas the jet on the right, even though it will take longer to build, will have a much better surface finish. Support removal. Support removal is a concern, especially when using breakaway supports. In the example provided, the support filling the larger hole on the part on the left will be difficult to remove since it is very deep inside the part. The same part on the right will not need supports in the larger hole since it is vertical, and these supports in the shallower holes will be relatively easy to remove. Part strength. Part orientation has a large effect on part strength. When stress will be applied to the part, such as the broom holder in the example provided, it is better for the tabs to be in the same layer as the body of the part on the right. The adhesion of one layer to another is weaker than the adhesion of the layer within itself. The part on the left would be much weaker when used as a functional model. You can think of it like splitting wood. It is easier to split wood along the grain, but very hard to go across the grain. If you have any questions, comments, or concerns, please feel free to reach out to MLC CAD Systems at 3D printer support at mlc-cad.com or contacting us with the number provided. Thank you.